Determine if the following series converges or not. We have two series here. For this exercise, we're going to use the integral test. So let's first review the integral test. Suppose f is a positive, continuous, and decreasing function on the interval from n to infinity. Then the infinite series here converges to a real number if and only if the integral below is finite. So in other words, if f satisfies these three conditions, positive, continuous, and decreasing, then to test whether this infinite series converges or not, we just look at the integral. Let's go back to the first question. Let fx equals 1 over x squared subtract 3x plus 2. Let's test the first function, the first condition, positive. So we know that x is greater than or equal to 3. So x squared is greater than or equal to 3x. Basically, multiply x on both sides. So multiply x on both sides because x is positive, so we can multiply that. So this, because x is positive, so when you multiply x on both sides, it's still greater than or equal. So this implies x squared subtract 3x is greater than or equal to 0. So that means that the denominator is greater than 0, right? So this is positive, so fx is positive. Obviously, fx is also continuous. Is fx decreasing? So let's look at the derivative of fx. So f prime x is equal to, first let's write this as fx as x squared subtract 3x plus 2 to the negative 1. We look at the derivative of this. And this is a composite function. So to take the derivative, so we have to use the chain rule. So we start from the outside function, which is a power of negative 1. So this is equal to negative x squared subtract 3x plus 2 to the power of negative 2. Multiply by the chain rule, we need to multiply the derivative of the inside function. And the derivative of the inside function is 2x minus 3. Let's rewrite this as 3 minus 2x divided by x squared subtract 3x plus 2 squared. And obviously this is less than 0 when x is greater than or equal to 3. Because the denominator is positive and the numerator is negative when x is greater than or equal to 3. So now we can see that all the three conditions are met. So we just need to look at the integral to see whether the series converges or not. So the integral from x from 3 to infinity, fx dfx. And first let's write this as limit t tends to infinity, 3 to t, fx d of x. And this is equal to limit t tends to infinity. And we can write fx as 1 over x minus 2 subtract 1 over x minus 1. You can check this. This is pretty easy to check. Fx is actually equal to this. And now we come here. And this is equal to limit t tends to infinity. Integral from 3 to t. You can write this as dx divided by x minus 2. Subtract 3 to t dx divided by x minus 1. Okay. So we can subtract 1 here. So d of x minus 1, d of x minus 2, sorry. So this can be written as d of x minus 1. Okay, once we write this, it's clear that this is equal to limit t tends to infinity. And now the integral here is just a log x minus 2. So it's a log x minus 2, evaluate the 3t, subtract log x minus 1, 3t here. So this is equal to limit t tends to infinity, log t minus 2, subtract log of 3 minus 2, which is log 1, subtract log t minus 1 plus log 3 minus 1 is 2, so log 2. Okay, so we can cancel this item, delete this item, which is 0. So if we combine these two items, log t minus 1 and log t minus 1, log t minus 2 and log t minus 1, so this is equal to limit t tends to infinity, log t minus 2 divided by t minus 1 plus log 2. Okay, so log t minus 2 divided by t minus 1 tends to 1 when t tends to infinity. So the first item tends to log 1, which is 0. So the whole item is equal to log 2. So which means the series converges because the integral here is equal to log 2, which is finite. Now let's look at the second question. Second question is this one. Again, use first letter fx equals 1 over x divided by log x. Let's see whether the three conditions are met. First, obviously, this is a positive. This is positive because x is greater than or equal to 2. And obviously, it's continuous. And it's decreasing function because the denominator is increasing, obviously. So all the three conditions are met. We just need to look at integral. So integral from 2 to infinity, 1 over x log x d of x is equal to, let's write this as 2 to infinity, 1 over log x times 1 over x d of x. This item is equal to d of log x. Okay? So this is equal to 2 to infinity, 1 over log x times d of log x. So this is equal to log and log x 2 to infinity. Now, because when x tends to infinity, this whole thing is infinity, so this whole item is equal to infinity. So, which means that the integral is not finite, which indicates that this series diverges. So we conclude that it diverges. Thank you for watching.